This is Miss Lee, and today we're going to talk about solving one-step inequalities. Make sure that you have your notes. Pause the video when necessary so that you can stay caught up in your notes. If you don't have your notes, then go ahead and take notes in your journal or on a piece of paper. Solving an inequality. It's just like solving an equation. We have the same goal. We want to isolate the variable. So take a look at our example. We have the inequality x plus 3 is greater than 8. Remember, to isolate the variable, we do the inverse or the opposite operation. So the opposite of adding 3 would be to subtract 3. And remember, what you do to one side, you have to do to the other side. So we're going to subtract 3 from the right side. So when we do our math, our 3's zero out, and it leaves us with x on the left side. Bring your inequality symbol straight down, and 8 minus 3 is 5. So our solution would be x is greater than 5. Now, this doesn't mean that x equals 5. It means that x can be any value that is greater than 5. Okay, it is all numbers that are bigger than 5. If this were an equation, it would say x equals 5, and it can only equal 5, but it's not. This is an inequality. Okay, let's talk about the properties of inequalities. The addition and subtraction properties of inequality say that you can add or subtract the same number to both sides of an inequality, and the inequality will remain true. It's kind of like keeping our scale in balance. If you added one number to the left side and added the same number to the right side, your scale was still in balance. Well, these are the properties for the inequalities. So let's do some examples. I'm going to do the same thing with equations. I'm going to kind of draw a little line underneath my inequality symbol so that I can see the two sides, the left side and the right side. My variable is on the left side. I need to isolate the x. There's a plus 5, so let's do the inverse operation and subtract 5. And what you do to one side, you have to do to the other side. Let's do the math. Our 5's zero out, leaves us with an x. Bring your inequality down. And negative 12 and a negative 5. They're the same signs, so we add them up and keep the same sign. So x is less than negative 17. Now let's graph this. On a number line, all you really need to do is put the negative 17. You're going to put your circle. Are we going to fill this in, or are we going to leave it empty? It doesn't say equal to. Our inequality doesn't have that equal to line, so we're going to leave it empty. And then look to see, who is the alligator eating. The alligator is eating the negative 17. So the negative 17 is large, the large number, which means that the x values are smaller and they go to the left. So these are the possible x values. Anything that is less than negative 17. Okay, let's try another one. I'm going to draw my line. This time my variable is on the right side, and I'm subtracting 3. So to isolate it, I need to do the inverse or the opposite, which is to add 3. I have to do it to both sides. Now let's do the math. 8 plus 3 is 11. Bring down the inequality symbol. My 3's zero out, and it leaves me y. So 11 is less than or equal to y. This is the solution to our inequality. So I'm going to put it on my number line. Here's my 11. I'm going to draw my circle. Do I fill it in, or do I leave it empty? This time we do have that equals line, so we need to fill in our circle, our dot. And then I'm going to look to see y is greater. The inequality symbol is open. The alligator's mouth is open towards the y, so y is greater than the 11. So the larger numbers go to the right of 11. And these are your y values. We also have multiplication and division properties of inequality. They say that you can multiply or divide both sides of an inequality by the same positive number. Underline this, positive is very important. By the same positive number, and the inequality will remain true. All right, some examples. Again, draw my line. My variable is on the left. It's being multiplied by 12. So the inverse operation would be to divide by 12. What you do to one side, you have to do to the other. Now let's do our math. 12 divided by 12 simplifies to 1x, or just x. Bring down your inequality, and 24 divided by 12 is 2. So our solution would be x is less than or equal to 2. So let's go ahead and put it on our number line. This is a big number line. I'm actually just, I'll do it right here. All right, do we fill in our dot or do we leave it empty? There is no equal line, so we leave it empty. And the inequality is open towards the 2. It's eating the 2. The 2 is larger, so that means all of our x values are going to go to the left because they have to be smaller. So these are the possible x values. And our last example, y divided by 3 is greater than or equal to 5. So I draw my line. The variable is on the left side and it's being divided by 3. So the opposite operation would be to multiply by 3. You have to do that to both sides. Let's do the math. Our 3 simplify to 1y, or just y. Bring down your inequality symbol. And 5 times 3 is 15. So our solution would be y is greater than or equal to 15. Now let's go ahead, I'm going to erase that, and let's graph it. Okay, are we going to fill in our dot or do we leave it empty? Well, there is an equal line, so we need to fill it in. I'm going to look. The alligator is eating the y, so the y has to be larger than the 15, so that means it's going to go to the right. And that's what our solution graph would look like. Y can be any value that is larger than 15 or equal to 15. Nice job.